Hello class. Today we're going to be going over 1.2 on the Pythagorean theorem and the distance formula. I'm going to jump right into it. We're going to go over quick notes. If you need to, you can pause and copy all these down, but I'm going to go through and explain it. Maybe you can write it down as we go through. First thing we're going to talk about is the Pythagorean theorem. This is a very big thing in Math 2. We're going to use this all year long. It's going to be your friend anytime we're dealing with right triangles. Not anytime, but most of the time we're dealing with right triangles, we might have to do Pythagorean theorem. Okay, Pythagorean theorem is a way to find a missing side length on a triangle if we already know two side lengths. Okay, so here's a triangle. I'm going to talk about a couple parts in my triangle. We have three sides to every triangle. In a right triangle, we have what are called our legs. Okay, the legs are connected by a 90-degree angle. So A and B are my legs here. Okay, and C is the hypotenuse, which should sound familiar because in our min comps, we label the hypotenuse. C is always the hypotenuse. Okay. So the Pythagorean theorem is basically one of your legs squared, so this time plus one of your other legs squared, that is equal to your hypotenuse squared, okay? Or as it's more commonly known, a squared plus b squared equals c squared, okay? That is very, very common. You're going to hear that all the time. A squared plus b squared equals c squared, okay? So in these examples we're going to go through, we're going to be given two of them. Maybe we're given this side length and this side length. So we're going to plug these in and then we're going to solve for C. Or maybe we're going to be given two side lengths like we'll be given C and A, where we're going to be solving for B. Okay. So we're always going to have two. We're going to be missing the third. And we're going to solve for that. And then we have what's called the distance formula. Okay. The distance formula is a way that I can find the distance between any 2 points just by plugging them into these. So normally you're going to be given a set of points, right? Points are 2 coordinates. We got x1 is what we'll call it, and y1. And then we're going to have a second point, which we'll call x2, and we'll call y2, okay? So if I have two sets of points, say this was like 1, 2, and 3, 4, we would just plug those numbers in up here. Okay, so whatever this number is, I put in this spot. Whatever this number is, put in this spot, so on and so forth. Okay, and if I plug it in like this, I get the distance between those 2 points. Okay, what the distance formula is basically me taking Pythagorean theorem and then rearranging it so that it just gives me my answer, okay? And it works for points. Anytime we are given 2 points, we can solve or find the distance between those 2 points, okay? We'll take a look at some examples. So let's jump into it. Example 1, find the length of the third side, if necessary, round to the nearest tenth. Okay, so I've got a triangle here. I've got 2 side lengths, and I need to find my missing side. So the first thing I need to do is I always want to know what am I solving for, okay? You're either going to be solving for a leg or you're going to be solving for the hypotenuse. In this case, because remember the right angle points to our hypotenuse, we have the hypotenuse, okay? So in this case, 20 is going to be our C, okay? Because the hypotenuse is always C. And then 12 can be either of our legs. Now, it doesn't really matter which leg it is. I can choose it to be my A, or I can choose it to be B. It's really up to you. In this case, I'm just going to choose it to be A, and I am solving for B, okay? So now I'm going to plug these into my formula. My formula is A squared plus B squared equals C squared. So here we go. We got A squared, so in this case, 12 squared, plus B squared. I don't know what B is, so I'm just going to keep it as B squared, because I don't know what that is. and that's equal to c squared. Well, c in this case is 20, so 20 squared. Okay, and now I'm just going to solve for b. Well, the first thing I want to do is get rid of my exponents. Okay, so I'm going to do 12 squared. Well, 12 squared is 144. I can't do anything with b, so I'm going to keep it as b squared. And that's equal to 20 squared, and 20 squared is 400. Okay. All right, well, I'm trying to solve for b, so I'm trying to get this all by itself. So I'm going to get rid of this 144. Well, I can do that by subtracting 144 from both sides of my equation. When I subtract 144 from both sides of my equation, I get b squared is equal to 400 minus 144, which is 256. And then lastly, I'm solving for b, trying to get it all by itself. It's squared right now, so I'm going to square root both sides. So I take the square root here and the square root there. I get b is equal to 16. Okay. A good thing about this lesson, a lot of the times it's going to ask us to round to the nearest tenth. Okay, so because we're rounding, we can actually just plug in 256, or the square root of 256 into our calculator, and it just gives me 16. Okay, now last class when we talked about simplifying radicals, these calculators don't give you the simplified version. So if it ever tells you to give it in exact form or the simplest radical form, then you're going to have to do these by hand. But you should always just throw it into your calculator first to see if it gives you a nice even number. So in this case, the square root of 256 gave me 16 as my answer, so I didn't have to do any simplifying by hand. Okay. And so I know that b, this side length right here, is 16. Okay, so I use this formula to find my missing side length. All right, let's give it another go. So I've got these two side lengths. Notice they're both connected by this right angle. These are both legs, okay? So it doesn't matter which one you call A and which one you call B, you're gonna get the same answer either way. I'm just gonna call 10 my A, and I'm gonna call 24 my B. I am solving for C in this case. All right, so I've got a squared plus b squared equals c squared. So 10 squared plus b squared, which is 24, so 24 squared, and that's going to be equal to c squared, which I don't know what c is, so I'm going to put a c there. Okay. And then we just go through and solve this. So 10 squared, I can do that in my calculator, or if I know what 10 squared is, 10 squared is 100. Plus 24 squared, I can type that in my calculator. 24 squared is 576, and that is equal to c squared. Well, I can combine these two. 100 plus 576 is 676. And then I need to get c all by itself, so I got to get rid of this square. So I'm going to square root both sides. Okay, when I take the square root of both sides, I can type it in my calculator, see if it's going to give me a nice number. And it does. It gives me 26. So 26 is equal to c. So this side length is 26. Okay. Question 3, one of the legs of a right triangle measures 17 centimeters and the other leg measures 3 centimeters. Find the measure of the hypotenuse. If necessary, round to the nearest tenth. Okay, so this time it gives me the information, but it doesn't give me the picture. So what I'm going to do is I'm just going to draw a picture. So here is my triangle. Okay. It's a right triangle. It says one of my legs is 17 centimeters. So I'll call that one 17. And the other leg is 3 centimeters. Remember, the legs are the ones connected by the right angle. The hypotenuse is always straight across from the right angle. I'm trying to find my hypotenuse here. So that's what I'm going to call x, or in this case, I'll call it c, just because we're using the a squared plus b squared equals c squared. Okay, where I guess 3 can be my a and 17 can be my b. So here we go. a squared, so 3 squared, plus b squared, so 17 squared, is equal to c squared. Whoops. To c squared. There we go. And then I can simplify this. 3 squared, 3 times 3 is 9, plus 17 squared. We can type that in our calculator. It's 289 is equal to c squared, because I can't do anything with that. I can combine these. So 9 plus 289 is going to be 298. So 298 is equal to c squared. And then lastly, I need to get rid of that square root. So I need to get rid of this square. So I'm going to square root. When I square root both sides, I'm going to type it in my calculator. And when I type it in my calculator, I believe this one is not going to give you a pretty number. But luckily, we don't want it to be an exact form. It says right here, we're going to round to the nearest tenth. So in your calculator, you can push the square root of 298, and you should get, it says 17.26267, and so on. Okay, we're rounding to the nearest tenth, which is just one decimal place. So in this case, it's going to be 17.3 is equal to C, because we're rounding, which saves us a lot of time, because otherwise we would have had to simplify this by hand. Okay. But since we're rounding to the nearest tenth, we can just put it into our calculator and get our answer. All right. Let's take a look at example 4. It says, graph a right triangle with the points 5, 6, and -2, 9, forming the hypotenuse. So this is the hypotenuse of my triangle. Okay, using the sides, find the distance between the 2 points in simplest radical form. Okay, so this one, simplest radical form, I cannot just have a decimal like I did over here. Okay, I need to simplify that radical by hand. Okay, so here we go. We're first going to draw a right triangle, which is what it says, graph, okay? This is our hypotenuse. Well, it shouldn't be too bad. We can just draw straight down here until we hit that point. Now I only went down 3 because that's where we line up with the other point. So this leg is going to be 3 units long, okay? And then my other leg right here is going to be 2, 3, 4, 5, 6, 7 units long. Okay. So I have a right triangle now where I've got this leg, and that's my hypotenuse. Okay. And then I'm just going to use Pythagorean theorem to solve for C. So here we go. These are my legs, right? Because this is the 90-degree angle right here. And this is the hypotenuse. We're solving for C in this case. We've got 3 squared, because that's one of our legs, plus 7 squared, because that's another leg of ours, is equal to C squared. That's what we're solving for. 3 squared is 9. 7 squared is 49. And we're still equal to C squared over here. 9 plus 49 is 58. So we got 58 equals C squared. And then lastly, we want to get C all by itself, so we are going to square root both sides. We get the square root of 58, okay? I am going to just type that in my calculator real quick. Just make sure it doesn't come out to a nice even number. When I type that into my calculator, it does not come out to a nice even number. I get like 7.6 blah, 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 which means I have to simplify this by hand, okay? So I'm going to do that real quick. We got the square root of 58. I'm going to say, okay, what can I break 58 into? Well, 58 is an even number, so I can break it into 2, and in this case, 29. 2 times 29 is 58, okay? 2 is prime, so we're done there. 29, I'm going to see if I can break 29 into anything. Well, you can type as many things as you want in your calculator. 29 divided by 2, 29 divided by 3, 29 divided by 4, so on and so forth. But you're never going to find anything because 29 is also prime, okay? So I've reached 2 prime numbers. There's no pairs here that I can bring out of my radical, which means this is as simple as it's going to get, okay? So the hypotenuse has a distance of the square root of 58. That is my answer in simplest radical form, okay? So sometimes they will simplify, sometimes they won't. But there's the distance of my hypotenuse, okay? All right, question 5. Find the distance between 2 points, rounding to the nearest tenth if necessary, okay? So this time I do not have a triangle. I just have 2 points. Now if we go back to our quick notes, this is referring to the distance formula. It's if you have 2 points and you're trying to find the distance between them. We're going to use this formula right here, okay? So the formula is the square root of x, one of our x's minus our other x. Both of that is being squared, plus one of our y's minus the other y, and both of those are being squared, okay? So let's take a look at this. The first thing I'm going to do, and the first thing I'm always going to do, is I'm going to label these points. Well, this is the x position, and this is the y position. This is the x position, and this is the y. So I'm going to call this x1. I'm going to call this y1, because that's the x and y for my first point. Then I'm going to call this x2, and I'm going to call this 9 y2, okay? So we got x1, y1, x2, y2. And now I just take these and I plug them straight into this formula right here, okay? So, and maybe I should, well, it'll be fine. I'm going to go through the formula. The formula is the square root, and it's kind of big, so I'm going to make mine kind of big. In parentheses, I've got x2, which in this case is 2, so 2. And the formula goes minus whatever x1 is. Remember, x1 is negative 7. We don't want to leave that negative behind. We include that negative there, okay? And that is being squared, plus, and then another parenthesis. It is y2, so 9 in this case, minus, and then y1. Well, y1 is negative 3. Again, we don't want to forget that negative. Make sure that that's included, squared. Okay, now I have 2 places I can go from here. I can simplify this. So if I chose to simplify that, I would have 2 minus a negative 7. Remember, anytime we have minus a negative, it's really like adding. So really, this is like 2 plus 7, which is 9. So 9 squared plus, and then we have a 9 minus a negative 3. Again, that double negative makes a plus. So 9 plus 3 is 12. So really, I have like the square root of 9 squared plus 12 squared. And then I can simplify this more. Or if you don't even want to do this step, you can actually plug this into your calculator, okay? This can go straight into your calculator. But if you do that, you want to make sure that you're putting both of the negatives, you're putting all of your parentheses, okay? So you choose where you want to plug it into the calculator. You can do it here. You can simplify a bit more. You can even go further than that if you wanted to. Like this is the square root of 81, because 9 squared is 81, plus 12 squared is 144. And you can keep simplifying as much as you want, but at some point you're going to want to plug it into your calculator, and I just get 15 as my answer when I plug that in, okay? So choose where you want to plug it in your calculator. But either way, we're going to get 15. And again, I can plug this into my calculator because I'm rounding. Okay, anytime we're rounding, we can always just plug it straight in. If it wants it in simplest radical form, that's when you can't plug it into your calculator. You'd have to add these, and then you'd have to do our little splitting like we did right here. Okay. All right, on the next side, it is spring break and you and your friends are excited to head to the Wild Wanders amusement park. Assume that you always take the shortest, most direct path between attractions. Each unit represents a meter. Okay, so every square here is 1 meter. Okay, question 1 says you enter the park and realize you are starving. Conveniently, there is a food truck stationed at 00. How far is the food truck from the entrance? So here's the food truck at 00. We walk in from the entrance, which is right here. We want to know what's the distance from the entrance to the food truck. Well, that shouldn't be too bad, right? If we just walk over there, we can see that it is 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 units, which up here it said each unit is a meter. So the distance is 8 meters. Okay. Question 2, from the food truck, you want to go to the milk jug, which is right here. Your friend walks straight to the right and then down, and you walk diagonally. Okay. Who walks further and how do you know? Okay. Well, let's see. Well, our friend is walking straight to the right and then he walks down. So our friend took 8 units to the right and then he took 4 units down. So our friend, he is walking 8 plus 4, which is 12 meters. Okay, now let's see how far you walked. Well, you walked in a straight diagonal line. Okay, so that's your path. Well, we need to find this distance right here. Well, how do we do that? We use the Pythagorean theorem. Okay, so you are going to use the Pythagorean theorem. Well, we know the lengths of our sides here, so we can just use those. These are the legs of our triangle, right? We're trying to find the hypotenuse. So we have an A, we have a B, and we are finding C. So I'm going to do 8 squared plus 4 squared is equal to C squared. 8 squared is 64, and then 4 squared is 16. That's still equal to C squared. Then I can do 64 plus 18, which is 80. So 80 is equal to C squared. And then we got to get C all by itself. So we got to take the square root of both sides. When I take the square root of both sides, because we are rounding to the nearest, well, it doesn't say to round here, but anytime we're talking about distance, so like a distance that I walk, it doesn't make sense to say, oh, I walked the square root of 80 to get over here. That doesn't make any sense in our brains, right? So I'm going to round this to a nearest number or nearest tenth so that I have some sort of idea of what this distance is. Okay, so I am going to actually plug in the square root of 80 into our calculator. And when I plug that in, I get 8.9 when I round it to the nearest tenth meters. Okay, that is what our C is. Now 8.9 to me makes a lot more sense than the square root of 80, okay? And because it's in this form, I can easily tell that your friend who walked 12 meters, he walked further, okay? So who walked further? The friend walked further. And our proof is just that math that we just did, okay? How much further did he walk? Show your work. Well, if your friend walked 12 and you walked 8.9, all we have to do is subtract those two, and then we'll get our distance. So 12 minus 8.9 is 3.1 meters. So he walked 3.1 meters further than you did. Later, you and your friends decide to go from the lazy pool to the Ferris wheel. So here's the lazy pool, here's the Ferris wheel, okay? What is the horizontal distance between the two attractions? So horizontal distance, here we go. I'm just going to draw it horizontally until I get to the Ferris wheel. The horizontal distance is, let's see, 4, 6. Okay, 6 is my horizontal distance. 6 meters, I should say. Okay, and then what is the vertical distance between the two attractions? Well, vertically, I'm traveling this far, which is 5 meters. So down here, I'll put a 5 meters. And then what is the direct distance between the lazy pool and the Ferris wheel, or the shortest path? Well, the shortest path is going to be horizontally, okay? So you can do this one of two ways. We already know what these distances are, so we can again use Pythagorean theorem because this is a right triangle. So a squared plus b squared equals c squared, where c is always your hypotenuse. Okay, so that's the first way we can do it. Or we could even look at these points. So this point, for example, is at -4, 2. And this point up here is at 2, 7. Okay, so we could look at the points and do it that way. Now, to be honest, the Pythagorean theorem is probably the easier way to do that, especially because we've already written down these distances, okay? But I am going to show you how to do it the point, just so you can see that extra practice. So again, this point is at -4, 2. So I'm going to write that down. Okay, I've got my first point at -4, 2. And I've got my second point at 2, 7. So 2, 7 is my other point. Okay. Now I'm just going to label these as my x1, y1, so on and so forth. So this is x1, this is y1, this is x2, and this is y2. And then I just plug it into that formula. Okay. If I'm plugging that into the formula, I've got x2, which is 2, minus x1, which is -4. That is being squared, plus y2, which is 7, minus y1, which is 2, being squared. Okay? Now, I can just plug this straight into my calculator, or I can simplify if I want. It doesn't really matter. I'll just simplify. 2 minus a -4 is really like a plus, so 2 plus 4 is 6. So we got 6 squared plus 7 minus 2 is 5, so 5 squared. Okay. If I keep simplifying, 6 squared is 36. 5 squared is 25. And then you can add those up together. 36 plus 25 is 61. And then I can plug this in my calculator. So again, we could have plugged this in our calculator, or I can plug this in our calculator. Square root of 61 is 7.8 meters. And if you choose to do it the a squared plus b squared equals c squared, you should get the exact same answer, right? 6 squared plus 5 squared, which, wouldn't you know it, is exactly what we have right here, right? 6 squared plus 5 squared. And then we take the square root of that, we get this exact same answer, okay? That is the end of our lesson. This is your check your understanding, okay? You're gonna have to solve for the missing side lengths here. Make sure that you are labeling which side is your hypotenuse, because hypotenuse always has to be C, okay? Here, you are gonna practice using the distance formula to find the distance between these 2 points. Okay, so use that equation. And then you've got 2 points here, and you've got to find the horizontal distance, the vertical distance, and the distance of the hypotenuse, right? Well, just a little hint here. If you're talking about the horizontal distance, x is horizontal, right? So if we're starting at -5, how many units over do I have to go to get to 3, right? That's going to be my horizontal distance. Likewise, if I'm starting at 2, how much units down do I need to go to get to -9. That's my vertical distance, okay? So we're thinking, how do I go from -5 to 3 for horizontal? How do I go from 2 to -9 for vertical? And then this one, you can either use Pythagorean theorem or you can use the distance formula, okay? That is it. When you get done with this, check your understanding. You can go get a homework paper and start working on that for the rest of class.